How to prevent deadlocks in multithreading. Imagine two friends reaching for the same cookie jar at the same time and neither letting go. That's similar to what happens in a computer program when threads get stuck waiting for each other. Deadlocks can freeze your program, making it unresponsive. But don't worry, there are ways to keep this from happening. One effective method is to set a clear order for locking resources. Think of it like assigning numbers to your locks. Every thread must lock resources in increasing order of these numbers. This way, no thread can wait for a resource held by another that's waiting for a third, preventing circular wait conditions. It's like everyone taking turns in a line, never jumping ahead. Another way is to avoid holding a lock while waiting for another. Instead, requiring threads to request all needed locks at once or releases current locks before asking for new ones. This stops the common problem where a thread holds one lock and waits for another, which can lead to deadlock. It's like asking for all your groceries at once instead of picking up one item and waiting for another. Using lock timeouts is also helpful. Instead of waiting forever, a thread tries to lock resources for a set time. If it can't, it releases what it has and tries again later. This back and forth reduces the chance of deadlocks because threads don't get stuck waiting indefinitely. Think of it as giving up after a short wait and trying again later. Non-blocking lock attempts, like tryLock, let a thread try to lock resources and immediately fail if they're unavailable. This way, threads can skip waiting and do other work or retry later. It's like knocking on a door and walking away if no one answers. Designing with immutable objects is another smart move. These are data structures that don't change after creation. Since they don't need locking, they eliminate deadlock risks altogether. It's like having a fixed map that everyone can look at without needing to hold a lock. Detecting deadlocks during runtime is also useful. Tools can analyze thread activity and spot deadlocks early. Once found, you can stop one thread or preempt resources to free everything up. It's like calling a tow truck to get a stuck car moving again. Finally, assign unique numbers to resources and always request them in increasing order. This simple rule stops circular wait conditions from forming. It's like always asking for the smallest number first, then the next, and so on. To put these into practice, analyze your code to find where threads might wait on each other. Use a consistent lock order across all threads. Try lock attempts with timeouts or tryLock to avoid indefinite waiting. Keep lock durations short and simple. Whenever possible, switch to immutable data or lock-free structures. And during debugging, use deadlock detection tools to catch issues early. By combining these strategies, you can keep your multi-threaded programs running smoothly without getting stuck in deadlocks. It makes debugging easier and your software more reliable.